Dear guys, welcome back to my YouTube channel. Now, yesterday's lecture I have discussed about Kepler's laws of planetary motion, and there I also told that the energy of the elliptical orbit solely depends upon the major axis. Okay, so Kepler laws of planetary motion is over. Now in today's lecture I shall going to discuss. Okay, sorry, in today's lecture I shall going to discuss uh, the differential equation of the orbit. Okay, differential equation of the orbit. Okay, so at first we have to write down the radial equation of motion, that is mr double dot minus mr theta dot square. This equals to fr. Okay, now we assume here r is, we take a new variable u, we introduce a new variable u such that r equals to 1 upon u. So what will be my r dot? Simply minus 1 by u square du dt. Now we have to convert this in terms of theta variable. So you can write du d theta, theta dot. Now again L we know mr square theta dot, that means theta dot equals to L by mr square, that means L by m into u square. So minus 1 by u square Lu square by m. So this is simply minus, this is du d theta. Okay, so this is minus L by m du d theta. Okay, we can write du dt as du d theta theta dot, and theta dot is L by mr square, that is Lu square by m. Okay, now what will be the value of r double dot? That means we have to differentiate this expression with respect to t. So minus L by m, we do it in terms of theta and take another theta dot. Okay, so this is simply minus L by m. What is theta dot? L by m into u square. L by m into u square, that is simply d to u d theta 2. Okay, minus L by m, or you can write this r double dot as minus L square u square by m square into d to u d theta 2. Okay, so you can write this. Okay, now we have to substitute these values in radial equation of motion. Okay, what happen if we substitute this? So m into r double dot means minus L square u square by m square into d to u d theta 2 minus m r, that means m by u theta dot square, that means L square by m square r to the power 4, that means u to the power 4. This you can write f of r, that means f of 1 upon u. Okay, so this becomes minus L square u square by m d to u d theta 2 minus L square u cube by m. This is simply f of 1 by u. Okay, so minus L square u square by m, you take d to u d theta 2 plus u, this equals to f of 1 by u. Okay, so what we get? d to u d theta 2 plus u, this equals to minus m by L square u square f of 1 by u. Okay, so d to u d theta 2 plus u, this is simply minus m by L square u square f of 1 by u. So this represents the differential equation of the orbit. Okay, so this is what this equation represents, the differential equation of the orbit. So differential term is involved here, and there is no r term. We have converted r variable into u variable. Okay, so this is the differential equation of motion of the orbit. Now let us do few numericals related to it so that the concept will more clear. Okay, so given that r equals to 1 upon 2 theta, so we have to find out the law of force. Find the law of force. This is the first numerical. Okay, r equals to 1 by 2 theta. So what will be my u? My u will be 1 upon r, that means 2 theta. So what will be my du d theta? Simply 2. And what will be my d2u d theta 2? That is simply 0. Now what would be the equation of motion? d2u d theta 2 plus u, this equals to f of 1 by u. So d2u d theta 2 is 0. Okay, and what is r? U. Oh sorry, there will be a minus m by l square u square, sorry. Okay, so my u will be 1 upon r, and this is simply f of r, and this is simply minus m into r square by l square. Okay, so what will be my f of r? My f of r will be minus l square by m r cube. That means you can write f of r, this is proportional to 1 upon r cube. So this is our result. Okay, so this is a simple numerical. Given that r equals to 1 upon 2 theta, we write u, find du d theta and d2u d theta 2, and substitute these values in the law of force equation, or you can say in the differential equation. So we have find that f of r is proportional to 1 upon r cube, or you, if you do it up to this, it is also fine, no problem. Okay, so this is the first numerical. Okay, now another numerical is that r is given a into e to the power b theta. We have to find the law of force. Okay, similar method. So what will be u? That is simply 1 upon r, that means 1 by a e to the power b theta, that means 1 by a e to the power minus b theta. So what will be my du d theta? 1 by a, and if you do it, then it becomes minus b into e to the power minus b theta. Again, if you differentiate this with respect to theta, this becomes there will be another minus b square. So b square by a minus minus plus, and another b square, this. So we have to substitute this value. So what would be the equation? d2u d theta 2 plus u, this is simply minus m by l square u square f of 1 by u. Okay, so d2u d theta 2 plus u, this is simply minus m by l square u square f of 1 by u. Okay, so if we substitute these values, then this is simply b square by a e to the power minus b theta, and what will be u? U is this 1 upon a e to the power minus b theta minus m by l square. And what is u square? U square, this is 1 by a square into 1 by a square into e to the power minus 2b theta, e to the power minus 2b theta. Or you can simply, you need not to put this value, you put there r square, and then you will write here r, no problem. Okay, so if you take common e to the power minus b theta by a, then what you get? You get b square plus 1 this is simply minus mr square by L square f of r. Okay, now u is simply 1 by r, that means 1 by a into e to the power minus b theta. Okay, now from which we can write e to the power minus b theta equals to au, that means a by r. So if we substitute this, what we get? E to the power minus b theta means a by r, and this is another a. So 1 plus b square, this is minus mr square by L square f of r. Okay, so a cancel, so what will be my f of r? That is simply minus L square by mr cube into 1 plus b square. Okay, so this is the result. Okay, so this is the result. So again we have seen that L square m1 plus b square is constant, so you can also write up to this. Okay, so this is the law of force. This is the law of force. Okay, now let us move to the last numerical of today's lecture. Okay, now our third numerical is that now a particle moves under the influence of a inverse square field. Okay, we have to show that its velocity can be written in this way: k by m 2 by r minus 1 by a. Okay, so if a particle moves under the influence of an inverse attractive force, so its velocity can be written in this way, and this is also related to central force elliptical orbits. How? We know that the total energy of a particle is nothing but the kinetic energy and potential energy, and what we saw for elliptical orbits, the total energy solely depends upon major axis. So you can put E equals to minus k by 2a, and if the particle has mass m and velocity v, you can write T as half mv square, and v is minus k by r. Okay, so you rearrange it, so half mv square, you can take k common, so this is simply 1 by r minus 1 upon 2a. Now what will be my v square? That is simply 2k by m into 1 by r minus 1 by 2a. So simply we can write k by m 2 by r minus 1 by a. Okay, so this is our required result. There is nothing, just we have to put these values and rearrange it. You have to find v, so find v square from and rearrange this and find v square, and the result is obtained. Okay, simple. So this is the lecture. Now one thing I have to mention here, that what I write in central force field, that is potential energy as minus k by r, and how it comes, oh sorry, minus k by r, how it comes. We know that gradient of potential is a measure of force, that means F equals to minus dv dr. So from which we can write dv equals to minus F dr. So what will be the expression of central force? Inverse square attractive force can be written as in this way: minus k by r square. Inverse square means 1 by r square, that is called inverse square, and attractive. Why? Because there is a minus sign in front of it. Okay, so if you put it, so k by r square into dr, and what if you do it integration r to the power minus 2 dr, so you will get minus k by r. And if, okay, so this is how the potential comes. Totally you have to consider this as a inverse square attractive force, that means 1 by r square inverse square, and minus sign is there, that means there is always attractive force. So just put the value of F and integrate this expression, you will find the corresponding potential. Okay, so this is the corresponding potential. Okay, So dear guys, if you don't subscribe my channel, then kindly subscribe it and share it and also like it. Okay. To get latest videos on physics. Okay, the video link will be given in the description box, and if you have any query or questions, then just write it in comment sections. I will be ready to give the result or the answer. Thank you.